Okay, so we're going to talk about tangents today, and specifically to a circle, tangents to a circle. So if we have a circle and you have a line that intersects the circle at exactly one point, that is called a tangent. So a tangent, by definition, it is a line that intersects a circle at exactly one point. And that point is called the point of tangency. We have been doing a lot of other diagrams where we've had a radius. Okay, we all know what a radius is. But if you have a radius drawn from the center to the point of tangency, that creates another special relationship, and that creates a right angle. I'm going to zoom in a little bit. Okay, so make a note here. A radius drawn from the center of the circle to a point of tangency creates a right angle. Okay? So when you have that situation, what's going to happen, or what you're going to see is that you have a circle with the tangent does not have to be a line. Remember, a line segment is a piece of a line. If I know that this is tangent and I draw my radius, I know that it's going to be perpendicular. So what's going to occur is you're going to end up seeing a lot of right triangles. So let's say that this whole piece is 12 and the radius is 5. Then how long is that? We're going to label that as x. Okay, so how long is that? So because you have a right triangle, you have 2 of the 3 sides. It goes right back to the Pythagorean Theorem. So 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. So 169 equals x squared. And then in order to solve for x, we're going to take the square root of each side. And we found x to be 13. Excuse me. So if I am looking for this piece, I'm going to label this piece as y. Okay, so if that is y, how long is y? Might want to pause and look at it for a little bit. Well, we know that this is also a radius, so this is 5. We just found x to be 13, so if I kind of pull this out of here, this is 5, this whole piece is 13, which makes this little piece 8. So you can find lots of missing pieces because of that radius. Okay, let's go ahead and do another example. I probably should label that other one example 1. If you have tangents that meet or intersect at a point outside the circle, then what happens is this piece here is going to be congruent to that piece there. So this little piece, let's say that this is 24. And we'll make this 3x minus 3. If you know that they are tangent, then I know that these are going to be congruent. If they are congruent, I can set them equal to each other and solve. So x would be 9. Another way to think of this, if you turn it this way, if I make like that witch's hat or the wizard's hat, you have two tangents that intersect at one point. So those two pieces are going to be congruent. You might even see some algebra come into the picture. Let's see if I can find a good one here. So we have tangent, and I'm going to say that this is 10. Radius is x. This is x, and then this piece out here is going to be 6. You're still going to use the Pythagorean Theorem. It's going to be just a little bit more work. So the side squared, the leg squared, plus the other leg squared equals this whole thing is the hypotenuse. This is not 6x. If you have that this is x and this is 6, the whole piece of it is x plus 6, not 6x. So I need to square my whole hypotenuse. So you're going to have to remember how to square a binomial. So x squared plus 10 squared equals, you can expand this if you need to, if you don't know the shortcut. And then it comes right back to FOIL. So firsts gives me x squared. Outers gives me 6x. Inners gives me 6x, gives me a positive 12x. And then my last gives me a positive 36. Notice what happens with the x squared, so don't panic that you actually have a quadratic. Because as soon as I subtract them from each side, they are going to cancel out. So 10 squared is 100, 12x, plus 36, and you're right back to solving. Subtract 36 on both sides. So now you have 64 equals 12x. And divide both sides by 12. So x equals something. Not a pretty number. Let's try that. I made a mistake here for a minute. 54 divided by 12. Nope. You get a nasty number. You get 5.3 repeating, which is the same thing as 5 1/3. If you are rounding, 5.3 or 5.33 would be fine.